In this episode, let's explore numeric functions under SQL scalar functions, covering why, what, and how. Let's get started. Why numeric functions? What is its significance? Numeric functions are the building blocks for quantitative analysis in SQL. They allow you to perform calculations, comparisons, and manipulations on numerical data stored in your database. By using numeric functions, you can summarize trends, identify patterns, and calculate statistics from your data. This helps you gain deeper insights and make data driven decisions. Alright, what are numeric functions? Here is a list of most frequently used numeric functions to perform calculations, manipulate numeric data, and obtain insights from numerical datasets. Let's learn the functionality with an example for each of these functions. Remember, these numeric functions fall under scalar functions category because they work on single value at a time, producing a single output for each input. First one, absolute function, in short called as ABS. It returns the absolute value, that is, a positive value of a numeric expression. Its purpose is to strip away the sign of a number and returning its magnitude. Let's learn with examples on PostgreSQL. Open PostgreSQL. Let's have the syntax of absolute function. It's as simple as select absolute function. So by definition, it gives us a positive value regardless of the sign of your input. So let's take example of a positive number as an input as well as negative number. Let's check absolute of 10 as well as let's check absolute of minus 10. The expected output for both of these should be 10. Let's check. See, for the positive number, it returned 10. For the negative number as an input, the output is expected to be 10. Let's see. Again 10. So that's how absolute works on a numeric constant. Let's apply this function on a table. Let's create a table with more numeric columns so that we can practice our numeric functions. Let me copy the create and insert script, which I'll be sharing in the description box link, so you can copy and practice for yourself. Let's execute the create script for sales data. With the columns transaction ID, product name, unit price, quantity, discount, tax rate, and total amount. Query executed successfully. All right, now let's do select star from sales data. So here is your table with the columns mentioned. So most of the columns here are numeric values and these are the products. Let's apply our absolute function on top of this. Here is the syntax to apply on a table. Select absolute of column value from table name. This is just an alias name. All right. Let us apply our column and table names here. Absolute function on discount column. I see a negative value as well as positive values under discount column. So let's apply absolute on top of this. Absolute discount from sales data. For us to properly assess, let's also add original discount as well as the product name. Let's execute this. The expected value, especially for tablet, the discount value should be minus 0.15. Absolute discount value is expected to have 0.15. Let's look at that. Absolutely. Minus 0.15 for tablet and 0.15 as absolute value. This is how absolute manipulates your data by giving you the magnitude of the value by removing its sign. Next, CEIL and floor. They're used to rounding numeric values to the nearest integer, either up or down. Think of the ceiling as above you and the floor as below you. Similarly, the CEIL function rounds a numeric expression up to the nearest integer, while the floor function rounds it down to the nearest integer. As simple as that. Let's check. Select CEIL is the syntax. Likewise, select floor. Let's use the same number as input for both the functions to see the difference in the output. CEIL of 3.14, the output is 4, while floor of 3.14 gives you 3. See, that is the difference. To show you the difference clearly in one SQL query, let's see 3.14 as original value. CEIL of 3.14 as sealed value. Let's execute this. See, original value 3.14 is rounded up under the CEIL and rounded down using floor. Alright, let's apply the same to our table select star from sales data. Select product name, comma, unit price. Product name, unit price, CEIL of unit price, comma, floor of unit price from sales data. See the clear difference of the unit price with both CEIL and floor. CEIL always rounds to the next number, whereas floor always rounds down. If you notice 300, when there are no decimal points, both CEIL and floor gives you the same number. What will happen with the negative value? Let's look at that. It works the same way. Minus 3.14. So earlier we have got sealed value as 4, floor value as 3, right? Now you see this as opposite because of the negative sign. See, minus 3 is the upper value, whereas minus 4 is the lower value to minus 3.14. This is the functionality of CEIL and floor functions. Moving to the next, round and truncate. Both the round and trunc functions modify numeric values, but they differ in how they handle rounding. Round function rounds a numeric value to a specified number of decimal places. For example, round of 5.678, 2 would return 5.68, rounding the value to 2 decimal places. It follows standard rounding rules. If the next decimal is 5 or greater, it rounds up. Otherwise, it rounds down. On the other hand, trunc function truncates a numeric value to a specified number of decimal places. It simply chops off the extra decimal places, essentially removing them without any rounding. If we take the same example, trunc of 5.678, 2 would return 5.67, truncating the value to 2 decimal places without rounding. Let's see the same in PostgreSQL. Let's begin with the syntax of round and trunc. Select round and select trunc. Let's give the same number 5.678, 2. Here also the same thing 5.678, 2. The first number indicates the number that we wanted to round or truncate, and the second number represents the number of decimal places that we wanted to round off the number or truncate the number. Let's execute these queries. 5.68. We wanted to round it for 2 decimal places. That's why after decimal point, you are seeing 2 decimal places. How is it rounding? After the second decimal place, the third place is greater than 5. That's why it is giving 5.68. Similarly, instead of 5.678, if we give 5.674, then the number would be 5.67, not 5.68. See, because it is less than 5. Let's also check what will happen is if the next number is exactly the 5. 5.675, 5.68. So greater than or equal to 5, then it rounds up to the next decimal position. What will happen if I don't give anything in the decimal places? Let's check that quickly. I'm using the round function, but I'm not specifying how many decimal places that it has to round off. In that case, it totally rounds off to the integer. Since it is 5.6, the output is 6. If I do round off 5.4, the output is 5 because it is less than 5. So the integer is rounded down. That's how round function works. Let's move to truncate. Let's do the same number. It directly chops off. No rounding, nothing. The 2 decimal places, how many ever places that we specify, it cuts and shares the number. Say for example, instead of 2, if I put 1, you know the answer, 5.6. So that's how it works. To show you in one single query, I wanted to put 5.678 as original, this as rounded, as truncated. Let's execute this. See, 5.678, when with round function 5.68, with truncate function 5.67. That is the difference between both round and trunc functions. Let's apply this on the table now. Let's execute select star from sales data once. Look at this. Now let's apply truncate and round functions on total amount of this. Copy this. Product name, instead of unit price, I'm using total amount. Let's execute and see. See, the original total amounts are mentioned here. 2281.45 rounded to 2281. Oh, let me add the comma 2. Comma 2, or let's add comma 1 for both. Since it is 45, it got rounded up. Whereas here, it doesn't check the next decimal number because it doesn't have to do anything with round up or round down. It directly cuts after 1 decimal position. So whatever is here, last number will be chopped off by giving only 1 decimal position. So that's how it works. Next one, sign function. It returns the sign of a numeric value, indicating whether the value is positive, negative, or 0. It returns 1 if the value is positive, -1 if the value is negative, 0 if the value is 0. Simple, isn't it? Let's check. Let's check positive, negative, and neutral values that sign function would retrieve. It returned the sign of 10 as 1 indicating positive sign of -10 as -1 indicating negative sign, and sign of 0 as 0. So if you want to change the sign of your value, then this is the built-in function to use. Let's check the same in our table. So you have unit price as minus 300 for a product name printer, right? Let's execute that quickly. I'm copying this. Sign of unit price. What is the expected output here? Except for printer, the sign of unit price is 1, and for printer, it is expected to see minus 1. Let's take a look at it. See, other than printer, it fetched the positive sign, and for printer, since it is minus 300, it fetched minus 1. That's the simple yet effective functionality of our sign function. Next comes power and square root. The power function in SQL is used to raise a numeric value to the power of another numeric value. That means it's a simple exponential calculation. The syntax is power of base, comma exponent. Here the base is the numeric value to be raised to a power, and exponent is the power to which the base is raised. Next one, square root. In short, SQRT function. This is used to compute the square root of a numeric value. It returns the non-negative square root of a given number. The syntax is direct, SQRT of a number. These functions are particularly useful in mathematical calculations and in scenarios where you need to perform either exponentiation or find square root of numbers. Let's see some examples. Its syntax is simple. Power of base comma exponent. Let's say base as 2, exponent as 3. It means 2 cube is nothing but 8. There you go. If we apply the same on the table, power of unit price, comma, 2. Let's do this. See, unit price is this, 1200 square, 800.75 into 800.75. These are the exponential values that we are seeing in the last column. That's how power works. Let's switch to square root. Similar syntax. Only value to which the square root can be applied to 2. Only one value, I mean. Let's apply the same to the table. Instead of power, make it SQRT. Execute it. All right. Unit price has a negative value in it. Remember? Let me do a select star. See, unit price has a negative and square root can be applied only on the non-negative numbers. So that's why it has thrown the error as cannot take square root of a negative number. Let's take a different value. Total amount. There you go. So that's the functionality of square root. Next, the mod function. It is also known as modulo operation, which returns the remainder of the division operation between two numbers. It calculates the remainder when one number is divided by another. The syntax is mod of dividend, comma divisor. Here dividend is the number to be divided and divisor is the number by which the dividend is divided. The mod function is used to determine if a number is even or odd, to find repeating patterns in sequences, or to allocate resources evenly among a fixed number of units. These are some sample use cases where the mod function is used. Let's look at some examples. Select mod of dividend comma divisor, right? Let's check 10 comma 4. What is the remainder if we divide 10 by 4? 2, right? So this is how you usually get it. A simple division operator, which gives you the remainder. Let's quickly put it on the sales data. Here, let us divide total amount by quantity so that you'll get the total amount for each quantity. Select mod of total amount comma quantity from sales data. See, let us also add the original column values under select. See, total amount by quantity, and this is the remainder from this division operation. These are the most frequently used numeric functions which will be useful for data analysis.